Hello students, this is the video number 3 of gravitation. Video number 3 of gravitation. In first video, we covered the variation of small g, means acceleration due to gravity. In second video, we will cover the satellite motion. In third video, we will discuss about the escape velocity. Okay? So, for escape velocity, first of all you have to know what is called gravitational field. So, gravitational field, write down in your copy, gravitational field. Gravitational field we can write as E is equal to force by mass. So you know the value of force, Gm by r square, and gravitational field means what? Gravitational field means, listen, the force experiences by unit mass. The force experiences by unit mass. By unit mass, that's why by m, and the mass of the object. So the force experiences by unit mass. Where? In a gravitational field. Where? In a gravitational field. So in a gravitational field of Earth, the force experienced by the unit mass, gmm, so one mass be divided. So gm by r square, this is the gravitational field. Now you tell me what is called gravitational potential. So finding, write down, just pause the video and write it down. Then gravitational potential V. For that we have to find the gravitational potential energy. So first we find out potential energy. Gravitational potential energy we can write as U, or you have to find energy means what? Energy means work done. So work done from infinity to R. So work done means force into distance, infinity to R. So students, I think you all know what is called work done. What is called work done or potential energy in a field? What is called work done or energy? Or what is called potential energy? Potential energy means the work done required to bring up unit mass. The work done required to bring a unit mass from infinity to any point. From infinity to any point, the work done required to bring a unit mass from infinity to any point. So from infinity to R, the work done required to bring a unit mass from infinity to any point. You know, in potential, where the current potential of current is potential difference. You learn potential in class 10. What is called potential? The work done required to bring a positive unit charge from infinity to any point. From infinity to any point is called potential. Okay. So for finding potential energy, you have to find from infinity to gravitational field. If you bring a mass of m, then what will be the work done? So work done is force and displacement. So you know the value of force, capital Gmm by r square into dr, integration from infinity to r. So potential energy U equal to work done is equal to Gm, outside constant term, infinity to r, dr by r square. Dr by r square, student. R square means, if you know the integration, you know r square means you can write r to the power minus 2 into dr. You know the formula, minus 2. What is the formula? R to the power n dr, integration r to the power n plus 1 by n plus 1. Here in place of n we can write minus 2. So minus 2 plus 1, it means 1 by r, because r to the power minus 1 minus. So minus 1 by r. Minus 2 plus 1 means minus 1. So minus 1 by r. So the result will be minus 1 by. Now if you put the limit, then what happened? Gm minus 1 by r from infinity to r. If you put the limit, first of all minus outside, you know, first upper limit 1 by r minus lower limit. So 1 by infinity means 0, so only 1 by r. So potential energy U equal to minus Gm, and there is another m. I missed out. So there is another m. So Gmm by r. That is the result of potential energy. Potential energy. Please write down. Copy it. Pause the video and copy the whole thing. Minus Gmm by r. And if you want to find the potential, gravitational potential, then you will write, for gravitational potential you will write what is called potential. Potential means work done per unit mass. W by Q, here we can write W by M. In current you will write W by Q, and in this case W by M. So W by M means U by M, means only Gmm by R. So in mass also cancel out, so Gm by R. This is called gravitational potential. Please copy. So our next item is escape velocity. So student, what is called escape velocity? Escape velocity. What is called escape velocity? Escape means it go out of the field. Escape means go out of the field. So the kinetic energy, the energy, minimum energy required to go out of the gravitational field, earth gravitational field, to overcome the earth gravitational field. So the velocity means energy, kinetic energy, half mv square, that involves some velocity. So whenever you want to calculate velocity, you have to find the kinetic energy. Velocity comes from kinetic energy. So you know the potential energy. So first of all, question number 1, there is a very important question for 3 marks question. What is called escape velocity? What is called escape velocity? The minimum velocity required to overcome the gravitational field, and it will go out of the field and will never return back. It will never return back again. This velocity is called escape velocity. Rocket, whenever we send a rocket with escape velocity, so that it will cover the or overcome the gravitational field. Say with me, what is called escape velocity? The minimum velocity. Minimum is very important word, because maximum, there is a huge range of maximum. So you have to mention the minimum velocity of projection, the minimum velocity of projection, or the initial velocity for which a body can overcome the gravitational field and it will go out of the field and it will never return back again. This velocity is called escape velocity. So the escape velocity is called VE, escape velocity. So you know, for escape velocity you have to cover the gravitational potential or gravitational potential energy. So you know the value of gravitational potential, which is equal to Gmm by R. We can ignore the negative sign because this is a value Gmm by R. This is called the potential energy. This is called the potential energy. And this potential energy to overcome, you need some kinetic energy, which is equal to half mv square. You need some kinetic energy to overcome this potential energy. Okay, so from this relation, kinetic energy, will get the velocity, which is called escape velocity, v square. I think you understood. So you have to overcome the potential energy. So potential energy formula Gmm by R, and you need the kinetic energy to overcome this potential energy. For this is a half mv square. Here v means the escape velocity. Write it in your copy 2 or 3 times so that you can easily write in the exam copy also. So mm cancel out. So v is square equal to Gm into 2 by R. You know the value of small g. Small g equal to Gm by R square. So in place of Gm, you can write, in place of gr square, Gm, in place of Gm, you can write gr square. So Ve is equal to root over of 2. Here we can write gr square by r cancel, so root over of 2 gr. See, in place of gm we put gr square. In place of gm we put gr square. In place of gm we put gr square. So gr square, r square are cancelled, so gr. So ve equal to root over of 2 gr. Students, you know this is called escape velocity. If you put the value of g equal to 9.8 meter per second square and r is a radius 6400 kilometer, convert it into meter and put here, so 11.2 kilometer per second. This is the result of escape velocity. This is the result of escape velocity. Now student, please pause the video and copy. Student, see, there is a very important thing. You know, orbital speed, if the satellite is very near to the orbit, near to the earth, then the orbital speed v0 equal to root over of gr. Am I right? If the satellite placed near to the earth, means the orbit is very near to the earth, in that case orbital speed equal to root over gr, and ve escape velocity equal to root over of 2 gr. So one more important relations we can draw from this. v0 equal to gr and v equal to this. From this we can draw another important relation between v0 and v, which is equal to ve equal to root 2 times of v0. Am I right? Root 2 times, so means the escape is equal to root 2 times of orbital speed. In your exam, there is another very two important questions might come in your exam. Question number one. Why moon has no atmosphere? Number one. Why moon has no atmosphere? Because students, see, the escape velocity of air may be higher than the escape velocity of moon. Actually, this is the escape velocity of earth. This is the escape velocity of earth. And you know the escape velocity of moon something very actually smaller than earth, because its g is also 1/6. So from this we can we know the escape velocity of moon is very less than the earth. That's why the escape velocity of air or the atmosphere is more than the escape velocity of moon. So that the atmosphere escapes from the moon surface. Or that's why moon has no atmosphere. The escape velocity of moon is very small and the atmospheric escape velocity is more than the moon. That's why they escape from the moon surface and they never come back. That's why moon has no atmosphere. Similarly, in earth there is no hydrogen. Why hydrogen gas absent in earth? You tell me. Because students, hydrogen is a light gas. Hydrogen is a light gas whose escape velocity is higher than the escape velocity of earth. That's why the hydrogen gas escape velocity is higher than the earth. That's why the hydrogen gas escape at the beginning. That's why there is no hydrogen in earth atmosphere, because hydrogen light gas, its escape velocity is higher than the earth, it escapes from the earth's surface. That's why there is an absence of hydrogen gas. This type of question might come in an exam from escape velocity. So this is a very important thing. Okay, in next video I will discuss the whole portion of gravitation. Okay, thank you for watching.